Which of the following is not a set? Is it A, the set with elements 3, 9, 15, and 21, or B, the set comprising pencil, pen, and board marker, or C, the set comprising pen, hoe, and cutlass, or D, the set comprising hoe, cutlass, and axe? This kind of questions have been used to disorient us from the meaning of a set for such a long time. When questions such as this are posed, the candidate is expected to choose option C in order to get the mark. This is incorrect. All the collections here are sets. What is a set? A set is a well-defined collection of distinct objects. That is what a set is. Now, this problem of thinking that objects must share similar features or characteristics in order to be grouped as a set is coming from the teachers. And unfortunately, even the educational materials that we are using, they misinterpret the phrase well-defined in the definition of a set to mean that the elements of a set must have similar features. What does the phrase well-defined mean as far as the definition of a set is concerned? That phrase means that the definition or the description of the set must be unambiguous, so that given any object, one can tell whether it belongs to the set or not. So the phrase well-defined means what it says. It doesn't mean anything strange. For example, if we say T is the collection of tall students, without any other statement on what it means to be tall, then T is not a set because T is not well defined. Or else one person considers a student who is 150 centimeters tall as a tall student. Another person may not. Another person may say you have to be 180 centimeters or above tall to be considered a tall student. So T is not a set because it's not well defined. When we group or we put a number of items or objects in curly brackets, we are saying that, and we label that curly bracket A, B, or whatever, we are saying that A is the set comprising those objects. So one can tell whether a given object is in the set or not. It's very easy to tell. What could be a better definition of a set than listing explicitly all its elements? Another thing that we are doing to sets that I am not happy about is this idea of types of sets. I mean, if you have a caption, types of sets, and under that you discuss finite sets, infinite sets, that's fine. I don't have a problem with that. But where you have types of sets as a caption, and under that you have finite sets, subsets, empty set, universal set, and all that are under the same types of sets, then you are misleading the learners. The phrase types of is usually used to introduce a list of non-overlapping categories. But where you have finite sets and subsets under the same heading types of sets, you are not doing justice to those concepts, because a set can be finite and at the same time be a subset. But putting them under those categories creates an impression in the mind of the reader that a set cannot be both finite and be a subset. All the things that you list under the types of, the impression you are creating is that one cannot belong to two of the categories at the same time. But that's false. A subset is not a type of set. It's about a relationship. If you say subset, then there is another set to which the given set, say S, is a subset. So an infinite set can be a subset. For example, the set of natural numbers is a subset of the set of real numbers. Both are infinite. A finite set can also be a subset. For example, the set comprising 1, 2, and 3 is a subset of the set of natural numbers. So please, we need to work on these things, and it's becoming popular. I mean, it's one person writes, another person copies, and at the end of the day, our learners are the victims.